Assalamualaikum. Now we go through the moment of a couple. First, what is a moment of a couple? A couple is defined as two parallel forces that have the same magnitude but opposite directions and are separated by a perpendicular distance d. So there are 3 points here, two parallel forces, same magnitude but opposite directions, separate by perpendicular distance d. Look here, this is a force upward, this is a force downward. This force is a opposite directions, have d. What is a d? D is a perpendicular distance. So, couple moment occur when two forces have same magnitude, parallel line of action, and opposite direction with respect to each other. Magnitude of the moment of a couple equals the force times the perpendicular distance between the line of action of the two forces. Same as before, equation of a moment equal to F force multiplied by D, perpendicular distance. Look here, there are two symbols. The first symbol like this, where we assume counterclockwise is always positive. The second symbol like this. This is some examples. Look picture number 1. You can see there are two forces here. The first to the right 30 Newton and to the left 30 Newton have distance 0.4. So to answer these questions, this is a moment of a couple because two forces opposite directions and have perpendicular distance. Alright, look here, this arrow is a clockwise. This arrow is a clockwise. So we assume before this counterclockwise moment is always positive. So this is a clockwise, negative 30 Newton time with the distance 0.4, and then you can get the answer negative something Newton meter. Alright, same with the picture 2, where to the right 40 Newton and to the left 40 Newton. Opposite forces. So distance is a 0.3 meter. Look, the direction is a clockwise. So we assume before this counterclockwise moment is always positive. So negative 40 Newton, because clockwise it's become negative, time with the distance 0.3. You can get answer. Okay, first example. There are two forces. The first force 90 Newton to the left, and at C force 90 Newton to the right. Look the directions. A to C. A to C. This is a counterclockwise. You know counterclockwise moment equal to F multiplied by D. So, counterclockwise moment is always positive. A to C is a counterclockwise, so positive 90 Newton multiplied by this distance 4 meter equal to 360 Newton meter. Second example, force 120 Newton. Positive or negative depends clockwise or counterclockwise. So, direction A upward to C. A to C. This is also counterclockwise. So, counterclockwise is always positive. 120 positive multiplied by 3 meter. 3 meter equal to 360 Newton meter. Example 3. This is a tree. Distance A and B is 3. Distance B and C is 4. So, here you can get the 5 meter. 3, 4, 5 meter. Look this direction. A to C. A to C. A to C. Also counterclockwise. Counterclockwise moment is always positive. So, 72 Newton positive multiplied by 5 meter. A to C is a 5 meter. So, you can get 360 Newton meter. Okay, exercise. Determine the resultant couple moment acting on the beam. Determine the resultant couple moment acting on the beam. Look this figure. There are 3 couple moments. First, 300 Newton upward and 300 Newton downward. Distance 3 plus 2 is become 5 meter. Second, 400 Newton downward and 400 Newton upward. Distance is a 2 meter. And third, 200 Newton to the right and 200 Newton to the left. Distance 0.2 meter. How to solve this problem? First, we already know counterclockwise moment is always positive equal to force multiplied by D. Force multiplied by distance. We solve the first one. 300 Newton looks this direction. This direction is a clockwise. So, you know counterclockwise is always positive. This direction is a clockwise. So, negative. Negative 300 Newton multiplied by the perpendicular distance 5 meter. How about the number 2? 400 Newton. This direction is a counterclockwise. Okay, counterclockwise. So positive 400 Newton multiplied by perpendicular distance 2 meter. And last, look 200 Newton here. This direction is a counterclockwise. Clockwise. So clockwise is a negative 200 Newton multiplied by 0.2 meter. And then you can get the answer in Newton meter.